All right, let's talk about something we've all lived with for decades. You know that sound, the whir of a fan inside your computer? It's just always been there. But what if it didn't have to be? What if that sound and the fan itself could just vanish? Today we're looking at a wild new way to cool our gadgets, using a chip that, believe it or not, actually breathes.
And this quote right here, it just says it all. Fans have been the only way to cool computers for 40 years. Meet the ultrasonic microchips that breathe air to cool your devices with zero moving parts. You got to pay attention to that last part, zero moving parts. That phrase, that idea, that's the whole ball game. That's what we're going to dive into.
And this really lays it out perfectly, doesn't it? On one side, you've got the past. 40 years of fans. They're mechanical, they're noisy, they take up a ton of space. But then you look at the future, solid-state cooling. We're talking completely silent, built right into the chip itself, and incredibly tiny. It's a night and day difference.
So, to really appreciate just how big of a deal this is, we first have to understand why our old friend, the humble fan, just isn't cutting it anymore.
It really all boils down to what you could call an electronics fever. Our devices keep getting more and more powerful, right? Well, that power creates a ton of heat. And our old solution, the mechanical fan, well, it's starting to lose the fight.
So what's causing this fever? The root of the problem is this number, billions. I'm talking about the billions of transistors that modern chips cram into a space smaller than your fingernail. It's an absolute engineering marvel, but it comes with a serious side effect: heat.
And here's a way to picture it. All of that power, all that energy, focused into just a few square millimeters, it generates a heat so intense that it's actually comparable to a hot plate. Seriously, think about that. There's basically a tiny little stovetop firing away inside your laptop. That's the problem we're up against. And this is where the fan really starts to show its weaknesses. I mean, we've all been there, haven't we? The constant drone of the fan when you're trying to focus, the slight vibration you can feel through the keyboard, the fact that our laptops have to be a certain thickness just to fit the fan inside, and that's before you even get to the dust that clogs them up, and the fact that eventually they can just break. So, if the fan is becoming the problem, what on earth is the solution? Well, it's a totally new way of thinking, a new kind of cool that's based on one simple, revolutionary idea: cooling with absolutely no moving parts. Now, the technical name for this magic is solid-state active cooling. It sounds a little intimidating, I know, but the concept is actually pretty straightforward. Instead of using spinning blades to push air around, it uses the inherent physical properties of solid materials to literally pump heat away from where it's being generated. Okay, so let's get to the really cool part: the breathing microchip itself. How in the world does a solid piece of silicon breathe?
It's actually a beautiful four-step dance. First, a tiny electrical signal zaps a special material called a piezoelectric membrane. When that happens, the membranes start to vibrate at ultrasonic speeds. We're talking so fast you can't see it or hear it. And then, this is the magic. Those vibrations create a steady, powerful little jet of air. And that microjet can be aimed with incredible precision, right at the hottest parts of a chip.
So what does all this get us? Well, the advantages are just incredible. First, truly silent operation. No noise at all. Second, zero vibration. And it gets better. This can be built directly onto the chip, meaning you can target hotspots with pinpoint accuracy. But here's the one that changes everything for us, for the devices we use every day. It enables so much thinner and lighter designs. And what's really fascinating is that these breathing chips, they're not alone. They're actually part of a whole new family of solid-state cooling technologies that are being developed.
And here's just a quick look at some of the other approaches. You've got things like thermoelectric cooling, which uses an electric current to move heat from one side of a material to the other. Then you have this whole group of caloric effects that use different fields, electric, magnetic, even just stretching a material, to make it absorb or release heat on command. The methods are different, but they all share that one beautiful, game-changing principle: no moving parts.
So, let's bring it all home. What does this actually mean for us? What kind of future does this kind of technology unlock?
Well, for starters, picture this: laptops and tablets that are way thinner and lighter than anything we have today, but are actually more powerful. And here's the kicker: they never, ever make a sound. Imagine rendering a huge video file or having 100 tabs open and your computer is just completely silent.
And this goes way beyond just laptops. Think about powerful smartwatches that don't get uncomfortably hot on your wrist, Or think about playing the most insane, graphics-intensive games on your phone or tablet with absolutely no fan noise and no performance throttling because the chip is getting too hot.
Which really leaves us with this final, exciting question. For 40 years, our technology has been designed around this one constraint. You have to leave room for a bulky mechanical fan. So if you take that constraint away completely, what do our devices look like next? I think the possibilities are going to be pretty amazing.